Welcome to my channel. Uh, this I'm back with another video. In this video, we will be going through some of the means common things that we have to do is to debug a slow application so that we can make it run in the given SLA or the agreed upon SLA. So let's get started. So many a times you might have this is also in a common interview questions as well in Spark particularly or even for distributed systems as well that how do you debug a slow application? So the first thing that should come into our mind is what does that slow application means? Where is that slowness coming from? Because a distributed job, for example, a Spark job, there are multiple places for or multiple reasons for which a Spark job can slow down. So to find out things like where it is slowing down, we have to understand that um, uh, all the kind of a places or kind of what you call context in which a Spark job can get slowed down. So once we have this mental model that okay, we are trying what we are trying to figure it out, then we can proceed ahead and see. So we will see in this video what are all the different places. So we have a slow job. The slowness can be due to the input source. Like for example, if the input layout is not properly there, if the files can be splitted or not splitted, is there a record skew? Like for example, if the JSON is there and the schema is not fixed, one we might have a very big JSON in one of the rows or two of the rows, while others have very small data. So that can also happen. Slow, it might be happening that the input is fine, that data read happened very fast, but there is just some stage which is running very slow. So that can be because of a slow map task. So map task slowness is slowness in executor, uneven partitions, even partitions with too many partitions or too less partitions, or the transformation is running very slow. So that can be another part. Then we have even partitions can also have predicate push down not being pushed down. So predicate push down not happening can be another reason. UDFs if we are using with even partition, that also can slow down. Or let's say in the transformation we are using a regex, that also can cause uh, slowness in the job. While uneven partitions, we know that there is a record skew, there is a task skew that might slow down the whole process. Uh, Also, in case of let's say while planning phase itself, if the DAG is too big or the number of number of times it has to compute the particular plan or recompute the particular plan can cause slowness. Or if the DAG is very big, the lineage is very big, that also can cause a job slowness. Or it might happen that there is nothing wrong with the job, it's with the infrastructure on which the job is running that is slow. For example, if you are using a multi-tenant cluster where multiple people are sharing the same resource, and let's say if some other resource is already consumed, let's say at T0 you submitted a job, so and your first stage was right, and you are using dynamic resource allocation and you got the resources, and once the stage was done, it deallocated the resources which were there and it was doing something else. By the time someone else launched the job and asked for too many resources, which consumed all the resources that were available on the cluster, and then your job will keep on waiting for the when a Spark driver will ask the cluster manager that like, I need more executors, it will not find any executors because it will not have enough resources. So in that case, also your job can slow down. Or if you might have that, let's say, for example, if you are running this on Kubernetes and the Kubernetes scheduler is getting slowed down for some reason, so again, your jobs will be slowed down based on that. So there are different places where this slowdown comes. We have to just be aware of all the places. So let's see in slightly in detail what are these places. For example, let's say why input layout does matter. So let's say if we have too many small files, so we will have too many smaller jobs. I mean, we will have too many smaller jobs running, and too many smaller jobs is because each of the tasks creates an overhead on the driver. So if we have too many tasks, that will create an overhead. So so we should look at trying to fix how to make the layout more suitable for consumption in the Spark application. Although we will not discuss the solutions. Solutions will be a second part of this video where we will discuss each of these points, like how we can correctly layout or fix these issues. So we'll see the solutions in the second video, but in this video we will discuss the problems first. So one is input layout, then we have non-splittable files. Let's say if a file cannot be splitted, or let's say the file that we are trying to, for example, JSON, we can't split a JSON in between. So we have to, the whole record has to be part of one particular file. So that kind of scenario, if it is there, we can't do a splitting. Let's say if we are using multi-line, so multi-line has certain challenges. Because we'll have to find out where the line breaks. So if it is possible, for example, here multi-line true, if we say it will create one single partition, hence it will be slower. If we set the multi-line to false, then it will not create a single file. It will create multiple partitions, hence it will be faster. So there are a few things on single line versus multi-line. Slow stage, so uneven partition. So this is something which is like we know that if the partition has too many records or partition has a skew, if the partition is uneven, then not all the partitions, all the tasks will work evenly, and their tasks capacity, the processing capacity is same, but some are processing more requests, some records, and some are processing less records. So hence, in that cases, there will be a straggler, and which will slow down the whole stage. But let's say if we have evenly distributed data, the partitions are even, but let's say if partitions are too small, then we will have the overhead of running too many tasks. If we have high task concurrency, means Spark is trying to execute these tasks concurrently in parallel based on cores. And if we have too many cores compared to the memory, there will be an increased overhead and a lot of GC will happen, and that will slow down the process. Or let's say if we have too few partitions, so in this case what will happen, that we are not utilizing the full parallelization capability of the system. So let's say if each executor is running on only one partition, so that, or let's say it can run on five, we can split even further, but we are not doing, and hence only one task, one particular executor is going on. So again, it's slowing down the process. And it may happen that with even partitions as well, if the transformations are slow. For example, let's say we are doing too many with columns kind of a process, that might slow down. For example, this one here, what we are doing for each column, means we have a dummy column list that we get from somewhere, and for example, let's say 300, and for each 300 columns we are adding these in new columns. This will slow down, and this is a valid scenario. Like for example, if we are doing feature engineering, we don't know the column names beforehand, we create feature 1 2 3 like that. So that's something which we can do, but not at a higher end. So we should not be doing this in a loop for 300 records. So that is something which we have to look at, that is there any issue, is there any for way for us to reduce this looping. And in higher version of, like we have with dot with columns, which we don't have to do a loop, it will create all those columns in one go itself. So that also is something we can take a look at. So the same question that we had can be changed with columns, and the job will run faster. So this is one. We can also use select. Now comes where we are not able to push down the predicate. So push down predicate is something where we, instead of filtering out after the data has been completely loaded in the system, while loading the data itself, if we are able to push the predicate down. For example, we can skip the whole partition, or if we can skip certain files or certain buckets, that will help us to reduce the data that is there. And if that is not happening, so that can cause slowness in the job, and that might happen because of, let's say, we are not using the right columns on which the table is physically stored, or we are not using the right data types. Let's say if the partitioning column is on date and we are using string, that might not match, and hence the pruning will not happen. UDFs can also be a cause of slowness. So UDFs, because it is a black box for the Spark, it can't optimize UDFs. So generally those are slow. If we are having too many shuffles, like we have a join operation, or we are doing a group by operation, which requires a lot of keys to be shuffled around, so shuffling can be another cause of slowness. Spill can also cause a job slowness, so we can look at the dashboard and find out which stage is doing the maximum spill, or which task is doing the maximum spill, and accordingly we can increase the memory of the executor. Slow executors, for example, if the executor is slow due to GC, that also causes issues. Big DAG is something which happens, let's say if we have AQE enabled and the job is trying to calculate too many, so how it does it? It creates a plan, analyzes the cost, then again creates another plan, analyzes the cost. So we have CBO, we have multiple plan can generation. So if AQ is in the picture, it might add overhead of more and more plan generations. So that is something which causes a very big drag. And also if we don't break the lineage, for example, we can break the lineage by just persisting the data. So that way the DAG will have two different stages, two different components to it. One will process till the point we have done the checkpointing, and then another one will start from the checkpointing pass. So that way we can reduce the DAG lineage that is there. As I mentioned, in a multi-tenant scenario, we can have slow clusters. Slow cluster can be due to scheduling delay, resource contention, or if there is a deadlock between jobs and apps. So this was the part one of the video where we see why the jobs are slow, running slow for a particular application. In the next video, we will see the solutions for these challenges that we see of jobs. So stay tuned. I will come back with a new video for the solutions.